Now let's take a look at what the division property of exponents are and what the rule for that is. We have 6 to the 5th over 6 to the 3rd. Well, we know 6 to the 5th means 6 times 6 times 6 times 6 times 6, and that 6 to the 3rd means 6 times 6 times 6. We should note that if we have a variable on top, or excuse me, a number on top and the same number on bottom, that's equal to 1, because we know it's a division problem and 6 divided by 6 is 1. So in this case, if we happen to have 6 over 6, we know that equals 1. And if we have 6 over 6, we know that equals 1. And if we have 6 over 6, we know that equals 1. And that leaves us with 6 squared on top. And when we look on bottom, there's nothing else on the bottom. So we simplify 6 squared over 1, and that simplifies to 36. Notice we had 6 to the 5th over 6 to the 3rd. We ended up with 6 squared, and we simplified it to get 36. For looking at x to the 4th over x squared, x to the 4th means x times x times x times x, and x squared means x times x. We know that if we have the same number on top and the same number on bottom, they cancel each other out, or they simplify to one whole because we divide anything by itself and we get 1. And that leaves us with x squared on top over 1 on the bottom, which we can also write as x squared. So in looking at this, we had x to the 4th over x to the 2nd, and we ended up with x to the 2nd. Hopefully there's something that's jumping out to you, and you're noticing that to divide numbers or variables with the same non-zero base, subtract the exponents or look for where the base is heavier and leave the remainder. For example, 5 minus 3 is 2, so 6 to the 5th over 6 to the 3rd is 6 squared. 4 minus 2 is 2. X to the 4th over x squared is going to give you x squared. Let's take a look at a few examples. Taking a look at the first one, we have 10 to the 7th over 10 to the 3rd. Now once again, we notice that we're going to have to simplify these completely. The first thing that we have to do is think that we're going to subtract 7 minus 3, which equals 4. So we end up with 10 to the 4th. But since we are asked to simplify completely, we have to note that 10 to the 4th is going to be 10,000. For the second one, x to the 25th over x to the 18, we subtract 25 minus 18, and that gives us x to the 7th. For the third one, notice that if we were to subtract these, we would say 24 minus 27 is going to give us a negative 3. But if we were to subtract the 27 first, we get a positive 3. This is how we know that the 5 to the 3rd needs to go in the denominator because we have 3 more in the denominator. This is why when we have a negative exponent, like 5 to the negative 3, it has to switch sides on the fraction bar because that 5 to the negative 3 is technically in the bottom into the denominator. And if we were to simplify 1 over 5 to the 3rd, we end up with 1 over 125. 3 to the 4th over 3 to the 4th, well, we can say we know that 4 minus 4 is 0, and we know what 3 to the 0 is, but we can also say if we have 3 to the 4th and we put 3 to the 4th on the bottom, we're going to end up with 1 whole because we have the same thing on the top that we did on the bottom. Same thing in the numerator that we did in the denominator. Looking at number 5, we have 12 over 3. Well, we know that 12 over 3 is equal to 4. Therefore, our answer has to have 4 in it. We then subtract our exponents like we've been doing, and 5 minus 1 is 4. Therefore, the answer is 4m to the 4th. Looking at the third one, we have, the sixth one. 6 over 18 is going to simplify to 1 over 3. When we write our answer, we know we're going to end up with a 3 in the denominator. Now, regarding the b to the 3rd, there's nothing to simplify with it, so we simply leave it as b to the 3rd. Number 7. 5 to the negative 3 over 2 squared. Well, we have to note that 5 to the negative 3 has to come down. So it becomes 2 squared 5 to the third under 1, which gives us 1 over 4 times 125, which gives us a simplified answer of 1 over 500. Looking at number 8, we have 2 variables. What we need to do is we're going to have to subtract each of these variables separately. For the y's, we have 6